This is an NAD 2600A power amplifier, and this is the definition of mint. There's not a blemish or a scratch on the outside, and the inside, as you'll soon see, looks absolutely brand new. There doesn't seem to be any functional issues with this, but it's nearing 40 years old, so I'll fully service and test this so that it lasts another 40 years. Good luck finding anything this clean, especially at this age. It's absolutely beautiful inside, and everything is original. Step 1 is to replace components. For each component type, I'll discuss why I'm replacing it and why I'm using the replacement I'm using. Let's start with the relays. I'm replacing the relays because over time the contacts can become pitted or oxidized. Oxidation is just a thin film that builds up, which can cause distortion, can cause your channel to cut out at low volumes, or can cause it to cut out altogether. This is a suitable replacement relay, not only because it's fully sealed, which should prevent the contacts from oxidizing, but also because the pinout and the specs are the same as the original. The new relays are installed and they look great. Before we move on, let's power this on and make sure we hear the click as it comes out of protection. Indeed. Let's move on. Up next are potentiometers. There are 2 for each channel. They look like this and this. These are used to adjust the DC offset and the idle current or bias. Similar to the relays, the internals of these original potentiometers can oxidize over time, which can wreak havoc on both the DC offset and idle current circuitry. The replacements from Bourne's are fantastic. Not only are they sealed, but also they're 25 turns, which means we have 25 times the resolution as the original single-turn potentiometers. This makes adjusting the DC offset and idle current very easy. The new potentiometers are installed. Let's move on to capacitors. I'll be replacing just about all of the electrolytic capacitors in this amplifier. If it hasn't started to happen yet, I guarantee within the next 10 years or so, specifically with some of these lower value caps, they're going to start to dry out. The capacitance will fall, the ESR or equivalent series resistance will rise, and the circuit will start to have issues. These are all high quality caps, either from Nichicon, Rubicon, Worth, or Panasonic, all at or exceeding the original specs. You'll see I do have some film caps here, and when we get to that point I'll explain why. For now, let's start with the right amplifier board. The right amplifier board has been completely recapped. I did replace 3 of the electrolytics with these film-style capacitors. So why use film? These offer a few advantages over their electrolytic counterparts. Number 1, they have a significantly lower ESR, or equivalent series resistance, and number 2, they have a significantly longer lifespan. There are a few other reasons that are more technical, but I think those 2 are reason enough. So why not replace all aluminum electrolytics with these film style? Well, above a certain value, it becomes impractical. These caps simply become too large or too expensive to replace. I think as a general rule, any aluminum electrolytic that's at 10 microfarads or lower can probably be replaced with a film style. Let's move on to recapping this left board. I'm done recapping the left amplifier board. I'm going to move on to the power supply section. Looks like there are about 7 electrolytics to replace here. I'm choosing not to replace these 4 larger caps. These ones tend to last much longer than the smaller values. These are also very high quality and they're measuring perfectly. No need to replace them. And the power supply is done. Let's move on to servicing this little volume board. Our little volume board has been recapped. Just like the relay contacts and DC offset and idle current trimmer potentiometers, these volume potentiometers are also subject to oxidation and buildup. But if they're working okay, no need to replace them, just clean them up a bit. We've reached the home stretch. Up next is the input board. There are 7 electrolytics to replace here. Due to its location, the input board was definitely the most difficult to recap, but I got it done, and I had to get a little creative with these 2 capacitors. Let's finish up. The last 4 caps have been replaced. Let's get it put back together and start testing. The amp's been powered on for at least 15 minutes. Let's see how close we can bring the DC offset to 0. Start with the right channel. And now the left. Beautiful. Now the idle current, we're looking for 7.5 millivolts. No need to worry about the negative sign, I just have the leads reversed. Now the left channel. And that's it. Let's take a look at the output with a 1 kilohertz sine wave. Yeah, they look great. This is rated for 150 watts into 8 ohms. On the scope at 20 volts per division, that's about 5 divisions. Let's see if we can hit that. That's right there. Sure can. Fantastic. I'm extremely happy with the way this turned out. Let's put the cover back on and finish up with the sound test. This beautiful NAD is nice and warm. I've listened to it for a while. It's fantastic. Thanks for watching.